Hi learners, in this session we are going to discuss about normal forms of CFG, in particular the Chomsky normal form and the Gribach normal form. So before getting in detail about this conversion process, let's try to understand the necessity behind this conversion. So we know that any context-free grammar, the productions will take the form. Onto your left-hand side, you will have a single non-terminal, and onto your right-hand side, you can have any kind of non-terminals as well as the terminals that can appear any number of times, including zero. So that's the representation refers to. So when you have such kind of things, normally what happens when you have this non-terminal which appears on the left-hand side, it could get expanded to any number of intermediate or leaf nodes depending on what you have. Okay, so according to the production that you have, suppose you have NT gives A. Okay, again A is a leaf node, it gets expanded to one child which is a leaf node. Suppose you have NT gives capital AB. Okay, now it got expanded to two non-terminals. Then if you have AA, it could get expanded to one intermediate node and one leaf node. Accordingly it goes. So when your structure is of this pattern, normally when it gets converted into your machine understandable format, the system will get into a problem of knowing how many and what kind of nodes will this particular production will generate. Okay, so which obviously leaves the system into a very difficult state without understanding the proper number of parameters that is coming in, and hence normally we go for converting the given statement into a standard form. So those standard formats are many. In particular, this Chomsky normal form is the best standard format that is available, which is based on the binary tree principle. So in binary tree, what happens? Any particular root node or your intermediate node can have a maximum of two childs, right? Either you can have two non-terminals which could be get expanded further and it goes on. When you want to stop, either you can use a single terminal. Let's say you have a non-terminal over here. I can stop expanding this by inserting a single leaf node. So this is A, this is B, this is A, this is B. Likewise, you can stop. So what is the option here? Either you can have a single child node which becomes your leaf node, or you can have two intermediate nodes which is the two non-terminal. Okay, by this way what are we trying to achieve is the standard format in which all the production should be rewritten, so that while moving on to production process, which is the conversion to machine approachable format, either assembly language or machine language format, we leave out with only two options, right? Onto your right of your production, you can have either single terminal or the two non-terminals. So this is one standard format. So let's move on to see how we can proceed with the procedure of this conversion. There are three preliminary steps which we need to follow. One is to eliminate the useless symbol. Second is to eliminate the epsilon production. Third is to eliminate unit production. So as the useless symbol indicates, we do have some symbols. Let's say if you are compiling a program, normally you are given with a warning stating that the declared variables is not used. Okay, that those kind of symbols are what we call as useless symbol, which will obviously not required for the proper execution, or it may unnecessarily get expanded, wasting the time, okay, and wasting the space that is required. Those needs to be eliminated. Then you have epsilon production, okay, which is unnecessary. Let's say A gives epsilon. Okay, so you might have replaced this in your earlier step, which could avoid some kind of computations. Then you have unit production, which is like a copy propagation. So all these three are the preliminary steps which we need to follow before getting into the conversion to Chomsky normal form. Once it is done, you can convert the CFG into the first normal form, which is Chomsky normal form. The pattern being a non-terminal can give two non-terminals or a single terminal symbol, only one terminal symbol. So either two non-terminals or a single terminal, as we have seen in the binary tree structure. Once getting converted, you can convert the Chomsky normal form into a Gribach normal form, which is of this format. A non-terminal gives a terminal followed by anything. Okay, non-terminal union terminal, the whole star. So by means of that, it is achieved that always you have a terminal which is starting, even though you have non-terminals over here, when it comes to the again it will follow the same category. So it is understood that always there will be an endpoint without infinite looping. So that's the format of Gray-Batch normal form. So let's try to understand what is an useless symbol, how to avoid it. A symbol is considered useless if there are two cases. One is if it is not generating. So what is generating? Obviously, the necessity of a grammar is to generate a word. Okay, in one or more multiple words, a grammar, which let's say if S is the start symbol, S should be able to generate words. Okay, so that is what generation means. So obviously we are in need of words, which is nothing but the combination of only terminal symbols. So what is a word? It is a combination of terminal symbols. Now, every non-terminal is expected to generate at least one terminal symbol. Okay, so any non-terminal X, let's say, it is expected to generate at least one terminal symbol. Okay, so terminal symbol, let's write as W. Okay, any word which we call as. If it is not so, we could take that into a non-generating state. Then the second concept is not reachable, right? So by definition, S is reachable, which is the start state, and all the non-terminal should be reachable from the start state. So S should give some symbol, okay, alpha, X, beta. What is X? It is the symbol. So when X is there, when from your start symbol, when you are able to reach X, where alpha and beta are some combinations of terminals and non-terminal, X is said to be reachable. In case, if you couldn't reach any non-terminal from the start state, we say it is in non-reachable state. So any symbol, if you feel it is non-generating, you can strip out. If you feel it is non-reachable, you can strip out. So that is how the useless symbols can be identified and deleted. Okay, how to identify whether there exists any non-generating symbols, right? So let's say yes. So for non-generating, you have to consider terminal symbols. So every symbol should be able to generate some terminal, which is a word. Okay, actually it should be a word. So this yes, if you take S could generate AB, BA, AS. Okay, so when I take BA, okay, so this is the terminal, and this A, when it gets expanded to again A, then again if you expand this, you will have B, A, and it goes on. Okay, it will never end. Automatically it will go on moving itself. So then, so you can stop this, then you go for the second alternate, AB. Okay, A is already a terminal. B, there are two options. In either case, if you substitute, you will end up with a word. So this S is, similarly you take A. Is A is generating? A can give only AA, right? This A again, if you substitute, it is AA, it will never end. And hence A is a non-generator. Okay, B, so it gives only terminal symbol, it is a generating symbol. C, it gives only terminal, it is a generating symbol. So that is the way you need to check whether the non-terminals are generating or not. Suppose in case if you find a symbol is non-generating, strip it out and all its alternates from the grammar. So your G dash will now become yes. So that's how the grammar will look like after eliminating all your non-generating symbols. Right? Now coming to not reachable. S is reachable by default. S can reach capital B and capital S. So both are reachable. So B can generate only terminals. Okay. And what about this capital? So actually this is small c. You could see here this is small c. And what about this capital C? Is it reachable from the start state? Definitely not, because we don't have any productions that is generating this particular part. And hence this is a non-reachable symbol. And after doing everything, will be left out with a grammar of this kind. So that's the simple way to understand how to eliminate non-generating and not reachable symbols. And we do have one more example here. First, you will try to eliminate non-generating symbol. Generate A, both A and A are terminals. A can get expanded to AS. So AS, if you go, again you need to know whether S is expandable. So I'm going for BD. Right. Suppose D is there. AB, we do have only one option, ADAA, and hence it's moving on. So we'll stop because we could not arrive at a decision on whether it is generating or not because D doesn't have an alternate. Right? So S gives A, B, C. We'll start with this A, and what is B? B can end up with the terminal B, and we have C. And what about C? C has two options. The other one option which is having only terminal symbols. So S could end up with the word. Okay. And hence S is generating. Now coming to A is A generating or not? A gives AS and S is already generating. So automatically A will get generated. Then B, yes, B can directly generate B. So it is generating. Now coming to C, C can generate ABB, so automatically it is generating. Then what is D? D always gets expanded to ADA. This will get expanded to ADA. Likewise, it moves on. And hence we don't have any probability of arriving at a word. And hence this is not generating. After this it will become S gives AAA or ABC. So that is after removing non-generating. Now to check whether everything is reachable. S is reachable. So A and B are reachable. From A and B or capital C, it's also reachable. So all the things are reachable. So that is the grammar after eliminating the useless symbols. Fine. Okay, let's move on to the next step, elimination of epsilon production. The epsilon is an empty symbol, we know. B gives epsilon means B is nullable. C is epsilon means C is nullable. These, when it comes on derivation, let's say S gives A, B and C. When B can be made epsilon, this particular leaf node will not be there, right? So the B itself will become epsilon. So we'll be left out with S gives AC. That's a simple concept, right? C can be made epsilon. So what does it mean? This entire strip will go on. So you'll be left out with either AB or A alone. So that's the concept here. And if you look at what are the nullable symbols, okay, B is nullable because you have B gives epsilon, C gives nullable because you have C gives epsilon. Now since you have A gives BC, since both are nullable, A can also be made nullable, right? You may have a question of what happens to S. S have A, B, C, all the three are nullable. So is S is able to get nullable? Yes, of course, but there is a special constraint that it is a start symbol and hence you cannot eliminate out of the context, right? Now, how to eliminate epsilon production? A very easy process, just substitute epsilon in place of all the symbols, okay? So, take one at a time, two at a time, all at a time, that's it. So, I'll write the production, just follow me. S gives A, B, C. This will remain as it is because these three have alternate productions other than epsilon also. Then I'm going to make A as epsilon, so I'll be left out with BC, B as epsilon which will leave AC, and C as epsilon which will leave out as AB. Right? Now let us make 2 as epsilon, that is AB as epsilon, you will end up with C, then BC as epsilon will end up with A, and then we'll end up with B if we make AC as epsilon. Okay, so that's what is after eliminating your epsilon productions. So I have made one particular non-terminal to be epsilon and 2 to be epsilon here. Now coming to the second production, you have BC or A as such, then you make 1 as epsilon, will be left out with C, then you'll be left out with B. Okay, then B gives BAC. Okay, this will remain. When I make A as epsilon, automatically will end up with BC. Then C gives CAB, or when I make A as epsilon, will end out with CB. When we make B as epsilon, will end up with CA, and both epsilon you will end up with C. So this is the grammar after eliminating your epsilon production. It's pretty simple that when you find a symbol to be non-terminal to be epsilon, you have to substitute epsilon in place. Okay, 1 at a time, 2 at a time, because all three could be nullable. So A could become nullable, which leaves a BC. B could be nullable, which becomes AC, and likewise it goes on. of elimination of unit production. So this is the grammar after eliminating useless symbol and after eliminating your epsilon production. Now coming to the elimination of unit production. What an unit production means? Any particular production of this format A gives B, okay, where there is a single non-terminal on the right is what we call as unit production, okay. What does it mean? A could be substituted with the productions of B. That's all, right? So when you go for expanding, A could get expanded to B. B can have its own production. So we are going to eliminate this intermediate step. We are going to apply all the alternatives of B towards A. That's the simple logic. Okay. Now look at what are the unit productions that you have. S can have C, which is an unit production. S gives A, S gives B, or all unit productions. Okay. Now we'll come in reverse one by step. Actually in C we don't have unit production, and in B we don't have unit production. In A we do have. So we will retain the C production as it is. C gives CAB or CB or CA or small c, right? I'll retain B's productions BAC or BC. Then coming to A, other than the unit production, let us retain other productions as such, BC or A. Okay, so when A gives C, directly instead of this step, we can replace C's production. So what are the C's alternatives you can give? CAB or CB, CA or C, right? Now we do have one more alternate. A gives B. So B's production also we need to include. This is more or less like a macro substitution which we do in a normal programming language. Then coming to S production, S gives ABC or BC or AC or B, right? So we have three alternates, C, A, B. So all that we need to include. So A will have BC, A, CAB, CB, CA, then small c, then BAC or BC. Okay. Now S gives A. A's production we have included. S gives B. B's production already it is there. S gives C. C's production already it is there. So this is the grammar after eliminating your unit production. Okay. Hope this is clear. So what we did, so normally the unit production goes like this. When you have A gives B, okay, A will get expanded to B, and suppose you have B gives alpha, this will get expanded to alpha. So we are replacing this unit production slide and replacing alpha directly as an alternate to A. That's it. So fine. Now with this grammar, what's the structure of CNF? We already saw that you can have productions of this format, A gives BC or A. So meaning that either you can have two non-terminals or a single terminal on the right. That is the condition. So how to proceed with that? Follow this simple strategy. Find out all the terminal symbols and give a new non-terminal name for each of them. Okay, we have three terminal symbols. So give a new temporary name. D1 gives A, D2 gives B, and then D3 gives C. Okay, so with that, start taking each and every production. I'll take one production and write first. So S gives ABC is the first alternate. Now the structure is you can have only two non-terminals onto the right. Okay, so what will I do? I'll retain A as such and I'll try to give a new name to BC, which is X1. Okay, now that what will happen? S gives AX1 will be there. Then this X1 can get expanded to BC and hence both can get retained to this format. Okay, now if you take BC, it is in that structure, AC in that structure, AB, BC all in that structure. BC I have repeated, sorry. Then A coming to this one. Okay, so what is the next alternate that we should change? S gives small c, capital A, capital B. So now this C, we know already we have created a new non-terminal. It could be replaced by D3. So it will become D3AB. So there are three non-terminals and hence what we do, D3. For this, I'll introduce a new non-terminal called X2, where X2 becomes AB. Okay. Keep in mind S already has AB as an alternate and hence you should not question on whether S could be used here. If you use, what will happen? All the other alternates will also come in place, which will change the meaning of your grammar. The meaning of the grammar should not get changed. Now this CB, yes, gives CB. What to do? This C, already we have defined a new non-terminal, so it will become D3B, which falls into this format. Similarly, S gives CA, so which will become D3A. Okay, so likewise it will go. When you have a terminal, you can leave as it is. When you have a non-terminal, we need to change. S gives BAC. So this will become D2A small c, okay, which will become D3. So in the next stage, D2 X3 can be there, where X3 can be expanded to A D3. And then at last you have one more production on S. S gives BC. This B can be expanded to D2 and DC can be replaced by D3. Okay. Now that we will write the alternate production for this grammar for better understanding. So you will have something like D1 gives A, D2 gives B, D3 gives C, and S gives A x1, where x1 gives BC. Okay, and the second alternate for AS, it is BC, which will be as such. Then AC will remain as such, AB will remain as such. Okay, then you have A. Then you have CAB will get expanded to D3 X2, where this X2 will be AB. Okay, and then you have CB. C will be get replaced by D3 and B will remain as it is. Then same way D3A. And the next thing is A followed by BAC. So BAC means you will have D2 replaced by B and you will have X3. Okay, defining A capital C. Sorry, A capital D3. Okay, so here it will be X3. Then at last you have BC which gets replaced by D2, D3. Okay, this is for S. Now coming to A's production, A gives BC. So it will remain as such. The second alternate also go as such. Then coming to CAB, C can be replaced by D3. Okay, and coming to AB, already we do have an alternate on X3. So directly you can use X2. Okay, you may have a question of why are we using it not in terms of S. X2 doesn't have any alternate. So the only possibility is to substitute AB. Then for CB, C will get replaced by D3 followed by B. Then D3A. Then small c will remain as it is. Then coming to BAC. Okay, so B for B we have to substitute D2. Then A small c. So A D3 which you can use X3. Okay, this production. Then at last you have BC which can be replaced by D2, D3. Then coming to B's production. Okay, it is BAC, BC. It is the same which will be D2 X3 or D2 D3. Okay, at last for C, C gives CAB, okay, which is D3 followed by AB. AB can be written as X2. Then you have CB where D2B. Then you have D2A followed by C. So now you look at all the productions, either you have two non-terminals or a single terminal onto the right. So that is Chomsky normal form. Okay, hope you enjoyed and understand this grammar how to get converted to the Grivach normal form. We'll see in the next video. Thank you.